Okay, so for today's notes, make sure you have page 80 out. And so we're going to talk about kind of the derivative, but this time from a graph. And so what we do know already is we know that the derivative is the slope of our tangent line. Okay, and so I'm going to kind of do this first one with us, and we're going to estimate it. And then I want you guys to try to do the rest of them on your own, like pause the video, do it on your own. So for x is -7, right? That's -1, 2, 3, 4, 5, 6, 7, right? And I have these points all out for us. What I want you to do is kind of, you can't zoom in unless you're using a computer, but if you're using a ruler, by hand, use a ruler, use a notebook or something straight, and kind of try to draw that tangent line here. Okay, so just try to really draw that straight like a tangent line, and count your slope. So, if we kind of drew that, I'm getting my slope looks like it's over 1, up 3, like if it kind of connected there. So up 3 over 1. So I'm estimating that slope, right? And so what I did again, I'm going to try to use a little bit of a smaller pen for this. So I drew my tangent line, right? So I'm going to kind of go here. I'm going to draw the tangent line where it's just hitting that point just one time, right? So there's my tangent line. I can even draw up. So I'm going to kind of go here. If this was a line, what's the slope of that line? Up 1, 2, 3 over. Mine actually even looks like it's up 1, 2, 3, 4 over 1. So actually a better estimation for me would be that my slope is about 4. Okay, so it's the slope of that line I drew. Okay, so that slope is 4. Now, is my slope increasing or decreasing? Well, this just goes back to like math 1, right? Algebra 1. Like y equals mx plus b. This is up 4 over 1. So it's increasing. Okay. Now, when I get to these relative max and mins, that's going to be if your slope is going horizontal. That's not increasing or decreasing. So I want you to think about, is that a minimum or a maximum there? And then what would be the equation of that graph? Again, this is just kind of an estimate because I don't know what the exact slope is, but we said the slope was 4. So, y minus, now this point here is at -7 comma -3. So it'd be y minus -3 equals 4 times x minus -7, and we can change those to positives. So what I want you to do is go ahead and pause the video, take some time, pause the video, and try to do the rest of these on your own. Okay, and you can even write here if you want to write this as f prime of -7 is approximately 4. So pause the video and try to do it for -6, -4, -2. Okay, so hopefully you've tried these on your own. At -6, again, if your answers are slightly different for the slope, that's okay. My answer I got about 2 for my slope. So again, what you should have done is drawn a tangent line here. If you have a ruler, that's kind of the best thing to do. And so my line, I saw it was going kind of up 2 over 1. So I said it was about 2. But if you got 3, if you got 1, that's fine. The main thing is that you got increasing here. Okay? And so then everyone should have y minus 0. But if your slope is different, as long as it matched up what your estimate was, that's great. And so that would be x plus 6. Okay, our next one would be here. And this one, the slope is actually 0. Okay, if you put undefined, that's wrong. It's 0. And this one does need to be 0. So what happens here is at -4, the tangent line is just going straight left and right. That's what our tangent line looks like. And so back from math 1, the slope of any horizontal line is 0 because it's up 0 over however many. So that slope is 0, and this is not increasing or decreasing. It's kind of neither. Okay, so instead, it's neither increasing or decreasing, and it represents a relative maximum. This is like the highest point. If we look at it, it's like the highest point of that curve. Okay, and our equation here would just be y equals 3. Okay, there's no x, there's there's no y because, sorry, y equals 2. That's 2. Y equals 2 because um, it's a horizontal line. So horizontal lines are always written as a y equals or an x equals. You could have done like y minus 2 equals 0 times x plus 4, but that would simplify to y equals 2. So if you had, y minus 0 equals 0 times x plus 4 essentially, um, oops, y minus 2, this would simplify to y equals 2. All right, for negative 2, I'm not going to continue to write all these. I'm just going to kind of talk through what my answers were. So for negative 2, I had that my slope was about f prime of negative 2 was about, I got negative 1, and that was decreasing, right? So here, this tangent line is going down, so that's a decreasing tangent. And then our equation would have been y minus negative 2, y minus 1 equals negative 1 times x plus 2. So that would be our equation. Next one at 1, I got that this one negative 1, this one I got was about negative 2. It's still decreasing. And then I had y, on this one, I had y plus 1 equals negative 2 times x plus 1. Okay. For f prime of 1, this was another one of those horizontal lines. We had 0. So this one does have to be 0. Okay, for the last two, if your answer wasn't quite exact, that's okay. Right? If you didn't have exactly negative 1 or exactly negative 2, they were estimates. But for these zeros, they actually really, these ones actually are 0. It's not even an estimate. These ones are equal to 0. And this one is at a relative minimum. It's like the bottom of that curve. Right? So it's the bottom of that curve here. That's a minimum. Okay, and so again, our equation, you could have written y plus 4 equals 0 times x minus 1, but that'll just simplify to y equals negative 4. Okay. At 3, our graph is increasing again, and I approximated my slope to be about 3. Again, if you got 2, if you got 4, that's okay. But the big thing is that we're increasing. And so you should have y plus 1. Everyone should have y plus 1. And you should have the x minus 3. But if your number 3, your slope was a little bit different, that's okay. For f prime of 5, this is another one of those zeros. That's another one of those horizontal tangents. Right? So up here, it's going horizontal. So that's a top. So that's a relative maximum. It's like the biggest point around it. And we should end up with something like y equals 4. And our last one, I estimated mine to be negative 5. This one was kind of a hard estimate. If you got negative 4, you got negative 6, you got something around there, that's okay. It's decreasing. And so we should add y plus 1 equals negative 5 times x minus 7. So, again, the big thing here is we were just kind of estimating and showing that, hey, we could estimate this by drawing our tangent line and then kind of getting the slope of that line. Right? So that's kind of what a derivative looks like on a graph, is it's that tangent line, right? That slope of that tangent line. So, kind of based on this, what are some inferences? Normally I would call on people, but since it's a video, we're going to just kind of talk about these things. So kind of the first thing that I'm noticing is that if our graph is increasing, so right, if the graph was increasing, right, then, and I'm going to put if the graph f of x was increasing, then what did we notice about our derivative? We noticed that our derivative was a positive value. So I'm going to put greater than 0. But what greater than 0 means in math is it means it's positive. Okay? So every time that we noticed that our graph was increasing, this is positive. Increasing, positive. Increasing, our slope was positive. Right? And so vice versa, kind of our second inference could be that if our graph f of x is decreasing, then our slope was a negative value. And this actually kind of makes sense from Math 1. You should have kind of already known this, but now it's just looking at with the curves, right? If the graph, if the curve is going up, it's increasing, then our slope is positive. So when we look at this, right, at any one point, we should be able to tell is the graph increasing or decreasing there. So, at this first point, our graph is increasing, right? We're reading from left to right. From left to right, we're going up. So that means that our slope is positive. Whereas over here, on this last point, going from left to right, we're decreasing. So that means that our slope was negative. Now, the other situations were, what about here, right, when our slope is 0? So this is a little bit tough because this one we called a maximum, and this one we called a minimum. So what's the difference? Well, the difference was this one was increasing first, and it changed to decreasing, right? Do we see at this point it was increasing, going up, 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 and it stopped and it went kind of down. That kind of makes sense. If you're going up and then you're going down, you're going to reach a highest point, a maximum. Whereas if you're going down, it's kind of like being at the bottom of a valley. We're going down, 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 down. We get to the bottom of our valley, and then we start going up. That's going to be a minimum. So kind of our third rule is that if, I'm going to kind of say, if f prime of x equals 0 and the graph changes from increasing to decreasing, then we have, or then f of x has a relative max. So that's where we get our maximum. And then for rule 4, you could just kind of flip that, right? So if f prime of x is 0 and the graph changes from decreasing to increasing, then f of x has a relative min. So those are just kind of some patterns that we noticed. Okay. So now what I want us to do is to kind of look numerically at the derivative at each point and estimate, estimated by finding the slope of the secant line passing through both points. Okay. So the secant line is, the line connecting -3 and 0. So on this graph, right, what our secant line would look like is, for x is -3, right, would be -1, -2, -3 would be this point here, and then 0 would be this point here. This is what our secant line would look like. Okay, that would be a secant line. Now we're not actually going to be using the graph, so we're not using the graph for this one. This is kind of just, I have a new table, right? And we're not using the graph because if you look at these points, 0, 1, they're not on the graph. So we're no longer using that graph. I just kind of wanted to show us what a secant line looks like, right? It's the line, if I had some curve, right, and here's -3, 2, and here's 0, 1. The secant line is this line here that's connecting them. So that's our secant. So the way we would estimate a secant line is I have 2 points, right? So I have an x1, I have a y1, sorry, an x2, and I have a y1, and I have a y2. So our estimate of that is going to be kind of going to that. Now, if I'm going to estimate at 0, okay, I'm actually not going to use 0. I'm going to use what's around 0. So if I want to estimate at 0, I want to use my secant line for the points around 0. So this is going to be kind of my first point would be -3, 2, and my second point would be 1, -3. So we're going to say f prime of 0 would be approximately the same as, okay, y1, so negative, or we can go, this is 1, so 2 minus y2, -3, over -3 minus 1, right? So this was x1, y1, x2, y2. If you had those flipped, if you had -3 minus 2 over 1 minus -3, that's the same thing. So anyways, we should get this as 5 over -4 or -5/4. So that's our slope. Now, how would I know if this is increasing or decreasing? Well, let's look at those patterns. We said that when the slope was negative, right? The slope was negative, then our graph was decreasing, and the slope is negative. So we're going to go ahead and say that this is a decreasing function. Okay, and so an equation of the tangent line here, we could write this as y minus 1 equals -5/4 times x minus 0. And the reason I got the 0 and the -5/4, or sorry, the 0 and the -1, where we're going at x equals 1. This is the x1 and the y1 that we're using. So that's the actual value at our point, right? We used around it to estimate our slope. Okay, so let's go ahead and do this exact same process, but for 1. So at 1, this is our actual value. That's where we are, but we're going to use the points around it to estimate our slope, right? Kind of like the y2 minus y1 over x2 minus x1. So say f prime of 1 is approximately, right? Here's y2, 0 minus, right, y1, 1 over x2, 4 minus 0. So we get that it's approximately -1/4. And again, we have another negative answer, so we're going to be decreasing. And we end up with y plus 3 equals -1/4 times x minus 1, because that's our, our x1 or y1. Okay, we can do it again for 4. You guys could pause the video and try these on your own if you want to. So for 4, the points around these, I'm going to write -7 minus -3 over 6 minus 1. That gives us -4 over 5. So again, we're decreasing, and we have y minus 0 equals -4/5 times x minus 4. And again, we were decreasing because we had a negative answer. And finally, we'll do f prime of 6. So around 6, our y2 could be 2 minus 0, and then our x2 would be 10 minus 4. That's 2 over 10, which is 1/5. This one is positive. So when we have a positive answer for our slope, we're increasing. So positive matches with an increasing slope. And then on our graph, y minus -7 is y plus 7 equals 1/5 times x minus 6. I totally messed this up. 10 minus 4 is 6. So 2 over 6. Hopefully you caught that. 2 over 6 is 1/3. So this should have been 1/3, not 1/5. Okay. So moving on to page 82, we have this graph, right? And so when we look at what intervals is g prime of x less than 0, right? Well, that would be where we're decreasing, right? So we want to kind of think, this is asking us essentially, when we see g prime of x is less than 0, we want to think, what does that mean on the graph? That means on the graph that the graph is decreasing. So we want to kind of connect that, make that connection. So where is our graph decreasing? It starts decreasing at -4, right? Because we're going x, and it stops decreasing at -2, right? This section is where it's decreasing, or at least our first section. So we're going to use our x values. So it's decreasing from -4 to -2. But then there's another part where it decreases. It starts at 1, and it just keeps going forever, right? We're just looking at our x values. So that's union from 1 to infinity. And they say give a reason, because g of x, or the graph, right? The graph of g of x is decreasing. So that's our reason. Okay, notice that I used parentheses, not brackets. The reason I used parentheses, not brackets, is if you remember at these points, it wasn't increasing or decreasing, it was neither. The slope was 0. But then starting after 1, it starts decreasing. Okay, so now, what are our intervals where g prime of x is greater than 0. So again, we want to kind of think that this is now increasing. So it starts increasing, just at the beginning it's going up, right? Where is our graph going up? Where is it increasing? So starting off at negative infinity, it increases all the way until we get to the x value of negative 4. Whenever we see intervals, by the way, intervals are always like our x, they're always x values. They're always like from here to here, right? And then also it's increasing from negative 2 all the way up to 1. That's where it's going up. So union negative 2 to 1. Again, we're going to use parentheses, not brackets for these always. Why? Because our graph g of x is increasing. Okay, and then what about where's the g prime of x equal to 0? Where's the slope equal to 0? So these are at all of our maximums and our minimums. So, at x equals negative 4, these are just values, they're not intervals, comma, negative 2, so also at x equals negative 2, comma, and x equals 1. I'm going to use another color for this. So these are where we have that horizontal tangent line, right? And these occur at like our peaks and our valleys, right? So at x equals negative 4, comma, negative 2, comma, and 1. Okay, and our reason here can be because our graph has a relative max or min. All right, and so that's kind of this graphical approach. Now, one last thing I do want to talk about is this normal line. So we've talked about tangent lines, okay? We're going to add in this new word called a normal line. So here we have a graph of f of x equals negative 1/2 parentheses x plus 1 squared plus 4. And so I want us to first start by drawing the tangent line of this graph at x equals 1. So at x equals 1, right, if we drew a tangent line, I'm going to kind of zoom in here. So kind of try to hit this where it just touches our graph once. Okay, so there's our tangent line, and we're going to use this to estimate the value of f prime of 1. So f prime of 1 is our slope. It looks like this slope is about down 2 over 1. It kind of looks like it's going to touch there. So it'd be negative 2. Okay, so if we're going to write the equation of our tangent line, y minus, now the y value here, this point is at 1 comma 2. So y minus 2 equals negative 2 parentheses x minus 1. So now here's kind of our new definition. Highlight this, underline this. But a normal line, this is something we're going to use in calculus from time to time, is perpendicular to the tangent line. Perpendicular meaning at a 90-degree angle. So if we were going to draw this normal line, right, we're going to start here, and we're going to make a perpendicular line. And if you remember about perpendicular lines, they always have opposite reciprocal slopes. So instead of down 2 over 1, it's going to be up 1 over 2. So you could kind of draw that point to help you out. So there's our perpendicular line. Right, so this is our normal line if you want to kind of label them. And then this was our tangent line. So we do want to make sure that we also, kind of remember that the slope is our opposite reciprocal slope, so it's positive 1/2, right? We're going to take negative 2, flip it, and change the sign, the opposite reciprocal. So it says, draw this and find the equation of the line. So I told you guys x1, y1, and m. I always use this setup, but for a normal line, I just add in the word, or the perpendicular symbol. The x1 and the y1 don't change. See how this point is the same point? So the x1 is still negative 1. The y1 is still positive 2. We got those from the original graph, right? You could have, if we didn't know the y1, if we didn't have the graph, you could have plugged in negative 1 here to get the y1. Now the slope was -2, but the opposite reciprocal slope we said is +1/2. We flip it, we change the signs. So y minus 2 equals +1/2 times x minus 1. This should have been +1. So